everyone. Again, my name is Brenda, and on the Microsoft blockchain team as a PM. And joined this team around half a year ago, and before that I was working on data center build-out, specifically on Azure Government. So worked on Azure for a while, and then before that I was working on Dynamics CRM, working on some professional software solutions. So yeah, it's been an interesting journey, and I'm excited to share with you guys about blockchain today. So before I get started, I just wanted to let you guys know, I just assume that no one knows much about blockchain, so I'm going to kind of start with a background of, hey, what is blockchain at a really high level, just so people can kind of understand, all right, how can these things be applicable to different scenarios? And then after that, I'll walk into a few case studies as well as some user scenarios so that you can better understand where is blockchain valuable, how can you use it. Then I'll go a bit more into our Microsoft strategy and roadmap. So hope you guys enjoy. So first of all, what exactly is blockchain? You hear about it, there's all this hype around it. What is it, right? So at the core, blockchain is a distributed ledger. And so when you kind of think about a traditional ledger, you have this central party or authority that's kind of controlling access to the ledger. And so anytime someone kind of wants to go and update the ledger, they go and they work with this central authority, basically saying, hey, I want to write this update. And the central authority will go and kind of validate your identity, make sure that the transaction that you want to make is valid before they actually go and update the ledger, right? And a blockchain system is actually distributed, and so all of the participants in the network have a copy of this ledger, and they can write directly to it. And so basically, it, in a blockchain system, doesn't require a middleman, which is pretty neat. And there's a few other aspects of a blockchain, which includes these four key components. So it's secure in that every transaction that you write is cryptographically signed, and so basically this ensures that you can have fraudulent transactions. Yes?
So what I'm going to discuss, what exactly is a ledger?
Oh, yes. A ledger at the very core is, it's like an accounting ledger, right? So it's basically a write once, read many times database. So you basically you write a transaction into the ledger and you can't erase it or edit it. If you write something incorrectly, you have to go back and basically write a corrective entry. It's basically you have, I actually have that here. So basically you have certain properties, right? So you can store a number of things in a ledger. It's mostly not only can you store things such as monetary value, but you can also store things like digital assets. So anything that can be represented digitally, if you think about it, can be stored on a ledger. For example, in this particular one, there's like a car. You can put like computer information, like your phone information. You can send messages. You can send like agreements and stuff. So anything that you can represent digitally can be stored in this ledger, right? And once again, to reinforce, the entire network has the same ledger. All right, so just to finish this part up. So blockchain is a secure shared distributed ledger. So it's distributed in that, everyone that's in the network has a copy of the blockchain ledger, and it's shared in that basically everyone that's participating in this network has access to the data, direct access to the data, and they can collaborate on it. And then we covered secure and ledger, so awesome. So that was a super quick, high-level overview of what blockchain is. And so now I'm going to dive a little deeper into where blockchain can provide a lot of value. And so when you think about blockchain technology, there's a few main goals that it supports. One is efficiency. And so if you think about efficiency, there's kind of a lot of things around processes that are really inefficient, right? So there's like cost involved when you have like manual verification of certain things, when you want to just increase the speed, when you want to have like real-time settlement and stuff. Blockchain can really assist with that. Another aspect of this goal is transformation. So kind of another area where blockchain can provide a lot of value is where you have kind of these cross-trust boundary workflows that you want to enable. And so right now, when I want to interact with someone that I don't trust, generally I'll have to introduce some sort of middleman that's mediating this transaction or this interaction. And so if you think about the transformation aspect, all the business processes where you kind of need to have a middleman right now, you don't really need with blockchain, since you have your own copy, you can trust it, it's secure, it's distributed, right? And so the business transformation comes from really that aspect of kind of rethinking what your existing business processes are and how you can really change them with this technology. And these aren't really like mutually exclusive necessarily, but kind of two large categories where you can see where blockchain is valuable. And so blockchain has a lot of hype around it, and a lot of the times you'll be like, you might think, all right, I have this cool scenario, should I use blockchain for it, right? And I think sometimes if you don't think through it carefully enough, you can actually, blockchain is not a super well-developed, like, there's been lots of people working on it for many, many years, so, there's still a lot of challenges with it, and so sometimes if you don't think about these questions carefully and you want to introduce it into any scenario, you can actually introduce unnecessary complexity, right? And so a few questions that you can ask yourself here, whether or not blockchain is appropriate. So, for example, is this a business process that crosses trust boundaries? Like I was mentioning earlier, if you need kind of a full transaction history with a single source of truth, blockchain can provide a lot of value there, right? Do multiple parties share data? If you want to have some sort of like real-time monitoring or real-time updating without having to deal with a lot of like the reconciliation or synchronization errors that happen when you need to share data across many different groups, blockchain can provide a lot of value there too. Is there a requirement for verification? Does your process have a lot of manual steps or manual checks that have to be done by a human or by, some process? With the immutability aspect of blockchain, it basically will do all that work for you. So it provides a lot of value there. And last but not least, can intermediaries be removed? That kind of ties into, the first one, but, if you want to have like quick settlements and, you want things to not have to move across many different parties, blockchain can also be really beneficial in this aspect. All right, so here's just kind of a list of various different industries, as well as some potential scenarios that you can actually leverage blockchain in. And I think when you think about the different scenarios that are listed here, such as asset tracking or asset transfer, you can add a lot of security and traceability to the transfer of various assets that you have, whether it be digital or like physical, right? And that also goes with like the supply chain transparency. If you have cross-organizational workflow, if you want to, instead of having manual intermediaries performing these transactions, if you want to have an automated workflow with different across organizations, there's a lot of potential here as well. And then also high assurance audit around the immutability aspect of blockchain, again, can also reduce a lot of costs and save you a lot of time when you need to perform these audits, right? So just a few examples of where blockchain can be pretty valuable across, an assortment of industries. So I also wanted to share a bit about some of the different customers that we've been working with. So the example that you see here is Webjet, which is a travel bookings agency. And if you kind of think about the challenges that these bookings agencies have to deal with, a lot of it is around managing many different partners that they work with, across airlines, across hotels, across the different customers. And so if you think about kind of the number of people that are working on a particular customer booking, there can be a lot of errors that happen. And so, that's really bad for customer satisfaction and things like that. So in this particular scenario, when you think about the actual customer booking, I'll go a bit deeper into smart contracts later, but basically it's a customer booking can be represented digitally as a smart contract on the blockchain, which provided a single source of truth for all these different partners that were involved in the booking process. And so it eliminated a lot of the errors and provided a lot higher customer satisfaction across all the Webjet customers. So that is pretty neat. Another one is around maritime insurance. And so to kind of give a bit of background around maritime insurance and the complexity of this scenario, when you think about insurance, like car insurance or something, generally it's like, okay, there's one insurer that insures my car. But in maritime insurance, it's a lot more complex since you're traveling from, point A to point B. You might cross a bunch of different country borders. You might cross, different like war zones or whatever. And at each location that you're in, you might not necessarily have the same insurer. You might not have the same insurance policies. Depending on the zone you're in, your risk rate might be higher, might be lower. And so a lot of these adjustments that happen across the length of the journey is difficult to track, especially with so many different people involved in the insurance process. And so when you think about how blockchain can be helpful here, instead of having, reaching the end of your trip and trying to figure out, all right, when did this damage occur, at what location did it occur, who was the insurer, how do I figure out that settlement process? If you think about, as the trip is traveling, in this particular scenario, there wasn't IoT devices on the boat, but if you think about kind of, all right, you're on the boat and you can like even just being able to input data about the state of the ship while it's traveling can be very helpful. And so with IoT, it can be even more powerful, right? Like you have devices on the ship that are emitting signals to the blockchain, and so at each point in time, you really know, the insurers can, see where the ship is, and they can see the state of the ship based on the devices, the IoT devices signals, and they can, adjust their insurance rates accordingly. So this is a pretty neat scenario as well. And then one other one, Bank Hapoalim, uses blockchain to streamline the bank guarantee process. And this one is kind of, when you think about financial services, there can be a lot of back and forth between a customer and a bank and trying to figure out the different terms, trying to figure out kind of the different situation that they're in to get a bank guarantee for, in this case, purchase like real estate. And so leveraging blockchain basically made it much easier for the customers, Bank Hapoalim customers, to get a bank guarantee easier without having to make so many trips to the branches, without having to really question like, all right, what's the latest state of my guarantee application? Do I have the next action? Does the bank have the next action? Who do I need to talk to next? It makes it much easier for you to see at each point in time who has done what and what the state of that bank guarantee is in. So another neat example. And I'm going to dive a little deeper into a trade finance scenario now, where you can kind of see the before and the after. And so in this particular example, for a standby letter of credit, the scenario is there's 4 parties involved. There's the applicant who basically wants to buy some goods from the beneficiary, and the beneficiary is asking the applicant for a standby letter of credit. Basically, what the standby letter of credit ensures is that if the applicant can't pay for the goods, then the beneficiary will still be able to get paid. Either basically the standby letter of credit will say this customer has enough credit to buy these goods, and if they don't, you'll still receive your funds from the advisory bank. And so there's 4 parties involved. The applicant has to work with the issuing bank, who has to work with the advisory bank, basically to work out the standby letter of credit terms before sending it over to the beneficiary. Once that happens, then the beneficiary will actually sell the goods, right? And so there's a bunch of arrows here. You don't have to read them all, but essentially this is a paper process right now, like email, papers, signing, and as you can see, people don't really know. There's lack of visibility, lack of transparency, and it's super inefficient. And so you might say, all right, there's this paper process, why don't we just move it to a digital process? And this kind of highlights why moving to digital isn't necessarily enough to solve all of the problems. So in this diagram, you kind of see how you have these siloed groups that each have their own data center and maybe their own app servers and database servers. And so at each point in time, you still have this problem where you don't really know who has the latest standby letter of credit or who has the latest version. And so you still have to figure out this reconciliation problem, right? Even though everyone is kind of on equal ground, you still have to have someone saying, this is the latest version, everyone's synchronized. And so moving to digital solves a lot of the problems, but doesn't necessarily solve them all. And so with blockchain, you kind of see how instead of having the 3 siloed environments that we saw in the previous diagram, you have this arrow kind of across the bottom. And I think this really illustrates in a good way how at each point in time during the process, every party that's involved has direct visibility into the state of the standby letter of credit. And so at each point in time, when the standby letter of credit gets updated, in this case, the standby letter of credit is represented in a smart contract. So each time the standby letter of credit gets updated, you see a smart contract update. And since everyone has visibility and they can see it at all points in time, they also know who has the next action. You can make things much more efficient. You always know what the latest version is. You always know who has the next action. You always know, like, hey, where is this in the current state of things? Is it almost done? Is it not done? How do I accelerate this? Who has the next action so I can go bother them, right? So this is a pretty neat scenario where you see how blockchain can really make a particular business flow much faster and efficient. So now yes?
Quick question on that. Does that imply that this has to be a linear process?
Excuse me?
The slide before has arrows flying all over the place.
Mm-hmm.
Here you see the implied somewhat that the process is now linear, sequential.
Right.
Is that actually the case?
Well, you can still have, I think, like, depending on the smart contract that you write, you can actually have, like, negotiation steps happen too. So it might not necessarily be 100% linear, right? Depending on the scenario, like if you have negotiation that has to happen, there might be an accept action that someone needs to have. If they don't, it will send back to the previous state of the business workflow. So this is, this arrow is just to illustrate like the end-to-end, kind of what's the start, what's the finishing goal, but you can have back and forth in between too. Yeah.
So my question is, how are users actually verifying their identity on the system?
How are they verifying their identity on the system? So blockchain doesn't really have their own, blockchain kind of has its own idea of identity, which is around addresses, right? So I'll talk about this a little later, but basically for an enterprise, you would have to integrate your blockchain identity with some sort of like your own identity system, whether it be like Azure Active Directory or like your Facebook identity or your Google identity, right? And so that integration work will happen. And so essentially what happens when you build out a blockchain application, you have to do your identity integration, and then when you're like writing some update to the ledger, you basically will have a private key that you're using to sign each transaction, and that's how basically you verify I'm this person and
So these are the keys, private, public keys.
yes, yeah.
Question.
Mhm.
So is Microsoft implementation is proprietary, or there's a standard body to follow
Implementation of what
the
specifically?
blockchain?
So we actually don't have a ledger implementation. So I'll talk about it a little more, but we don't have, like, we're not building out a ledger.
Okay.
Yeah. So, moving right along, now that we kind of hear about how great blockchain is, you're like, wow, this is awesome. Why isn't everyone using blockchain right now, right? So, the key point here is that blockchain wasn't built for enterprise. So, at the core, blockchain was built for cryptocurrency, right? And so, if you think about the cryptocurrency world, it's huge networks, no one trusts anyone, and so you run into a lot of issues, such as, a lot of the ledgers that are available today aren't necessarily enterprise grade. So for example, ledgers that are designed for the public network lack a lot of things that enterprises care about, such as confidentiality, scalability, and governance, right? And so when you think about enterprises wanting to move blockchain applications to production, it's just not super realistic because some of these core requirements are not there. Another one is around smart contracts. So smart contracts weren't designed to take advantage of a lot of the enterprise code bases. So right now when you write a smart contract, you kind of have to figure out, hey, what's the ledger that I'm using? You have to write a very specific smart contract in a specific language for a specific ledger. And so, it's not super modular. You can't do things like call data that's not already on the blockchain. So lots of limitations around smart contracts right now, which make it difficult for enterprises to move forward as well. And then last but not least, there's this problem that we like to call the blockchain island. So after you stand up your blockchain network, it's kind of difficult to figure out like, hey, how do I integrate this with my existing system so that I can actually use this in a meaningful way, right? Instead of just having a blockchain network on the side where you are playing around with it and it's not really working together with your existing systems. So I'm going to talk a bit about our strategy and our roadmap and how we're solving these issues. So with Microsoft, we have 3 pillars, kind of. We have blockchain on your terms, integrated with your business for the enterprise. And so blockchain on your terms is really just, making it an open marketplace scenario where, we have this open cloud mindset. We have a lot of regions. We have lots of partners that we work with to really figure out with you and with the customers, like, hey, what is your use case scenario? It can be very specific. You can pick and choose what fits your needs the most. Next, integrated with your business. This is around kind of that blockchain island problem where if you want a meaningful blockchain application, you kind of need to integrate it with the systems that you have right now to make it meaningful. And then for the enterprise, this is around kind of those challenges we talked about earlier around, ledgers not being enterprise friendly, smart contracts not being enterprise friendly. We're doing a bunch of investments there to make it easier for large organizations to really think about blockchain seriously and move it to production. So first I want to talk about our template offerings. So we have a lot of templates that are available in the Azure Marketplace. And so we have a lot of choices because there really isn't a one-size-fits-all ledger. Depending on your business scenario, you might want to use one ledger over another. And so we have a really diverse ecosystem here where you can select which one you want to use. And essentially what this is you have a really easy way to deploy a blockchain network. And so instead of having to set up all the VMs yourself, configure all the networking yourself, what you can do is go to the Azure Marketplace or go to the Marketplace through the portal, select the ledger that you want to use, and essentially all you have to do is go through the Marketplace deployment and you put in some configuration information such as how many members you want in your network. And after you do that, you click create, and then it will spin up a private blockchain network for you in a matter of minutes. So really lowers that barrier of entry. And our templates come in a number of topologies, so you can choose which one you want. The first one that we have is kind of this dev test scenario where you have a single node, and that's your blockchain network, just for you to experiment with. We also have a single member, which simulates multiple organizations within a single organization. And so this is kind of around, hey, if you have a single subscription and you want to have this network simulation, how do you do that? And then last but not least, we have our multi-member, which is closest to the real blockchain scenario where you might have multiple organizations across different Azure subscriptions, across different regions. How do you connect that type of network together? And so we have a number of topologies you can choose from.
When you say the topology, what happens here? What happens with these servers? Is it storing the ledger or is it?
So depending on which one you choose, it'll spin up like a different number of VMs and it'll connect to different sets of VMs. So for example, in the multi-member, like we have a leader template where it's like, all right, I'm the first one that's gonna start this multi-member network. And so you have different configuration information put in there. And then if you want to join as a member to that network, then you have to have like endpoints for particular VMs in that first network for you to join to it. And so depending on which template you choose, you might have different resources that actually get deployed into your subscription. All right, so one of the products that we're working on is called the Coco Framework. And Coco stands for Confidential Consortium. And we have a white paper on it if you want to learn about all the technical details here. But essentially, the Coco Framework is kind of this wrapper that you can put around a blockchain ledger. And it offers things like scalability, confidentiality, and consortium governance, which were the issues that a lot of enterprises have with existing ledgers. And so with scalability, you kind of think about existing ledgers in like today, and a lot of the times you don't get things like database-like speeds when you're trying to run a bunch of transactions, right? And so when you think about it, it's not super practical for enterprises, confidentiality, and this scenario is around, like, let's say I have some private network and I want to interact with one of the counterparties, but I don't want everyone else to know kind of the details of my transaction. Maybe I don't care if people know that we have a deal, but I don't want them to know like the details of it. Right now, once you write things to the blockchain, everyone can see it. And so how do you kind of have these richer confidentiality models around your smart contracts? And so Coco Framework allows this, and also consortium governance. Right now, when you have kind of this private consortium, or even a public consortium, like when someone wants to join, you kind of have to have people that are agreeing to let this person join. So it's like, all right, right now everyone kind of has to manually get together and agree that this person wants to join, we're gonna let them join. If you wanna make that more of a configurable model, such as, all right, how about we have like 50% vote for this person to join? It's difficult to do that right now with existing ledgers, and so Coco Framework allows for that also. And we have an enterprise-friendly platform here. So at the bottom, you kind of see our enterprise ledger offerings, and in the middle, you can integrate it with the cloud services that you already use, such as identity integration, which we were talking about earlier. As I also touched upon earlier, your identity and your transactions is super dependent on keys, like public and private keys, and so how do you manage your keys so that they don't get compromised? So your key management, if you want to do things like perform analytics on your blockchain transactions, how do you do that? And so that's kind of the integration with the existing services that you're already using, and then the top is kind of your existing applications and workflows that you want to work with as well. So this is kind of just a view of how these things would tie together. And now I want to talk a bit about smart contracts. So basically, a smart contract at the simplest level is a paper contract, and you basically codify it. So you take all the components of the paper contract, and you kind of break it down, and then you break it down into code form, and then you can translate it into a distributed application. And so some of the challenges that we talked about earlier around smart contracts, first of all, around security. So like I said, you can't really store proprietary information in a smart contract or any really confidential information on a smart contract, since once you publish it, everyone can see that. Everyone in your network can see that data, right? So that's one of the challenges here. And also, if you want to do things like call some off-chain data, such as, let's say I want to get the interest rate for my, to calculate some sort of deal on this smart contract, you can't do that right now without compromising the integrity of the ledger. So challenges around security there. And then scale is around the different languages I was talking about earlier. You can't really write one smart contract and use it on many different chains, because they might not necessarily be using the same ledger protocol, right? So for example, if I want to use an Ethereum chain, I have to write all my smart contracts in Solidity. If I want to use Hyperledger, I have to write it in Go. And so I can't just easily port them, and so it's really difficult to scale. So another area that we're working on is this idea of Cryptlets. And so when you kind of think about a traditional three-tiered software architecture, you have three layers, and you have your data layer, business logic layer, and your presentation layer. So that's kind of how things are split up right now. With the early blockchain distributed application architecture, you have this large monolithic data layer with all your data and also all your business logic all at the bottom. And so that's kind of why, if you think about it, all right, all these challenges we were talking about earlier, you can kind of see why it's difficult. And so the idea with Cryptlets is that you will move out the business logic into this middle layer to make it easier to do the following things, such as call off-chain data. So basically what Cryptlets allow is for you to do things like go off the chain, get some data, or compute some sort of thing without compromising the integrity of the ledger. also allows for things like productivity. So you can code in languages like C# and then be able to port it across different ledgers as well. And then, modularity, you write it once in the language that you want to use it in, that you're familiar with, and then you can use it across many different ledgers. And so one of the questions that I get a lot here is kind of like, all right, so if you move the business logic off the chain, how do you make sure that no one's tampering with it, right? So this leverages a technology called trusted execution environments, which is basically like a software or hardware enclave that has the code or the business logic or whatever it is that you're trying to run off chain. And when you call it, it will run the code, and then it will come back with the result that it computed, and also an attestation. Attestation basically provides a signature. Basically, you can compare it with, so you know that the code in there hasn't been compromised or tampered with. And if it has been, then your attestation will not match. And so there's a lot that you can read up on trusted execution environments. So I won't go super deep there, but there are some links that I can share if you want to learn more. And so last but not least, we're working on a product called Application Builder. And to kind of set the stage here, there's lots of challenges when you're trying to build out a blockchain application, right? So right now it takes a lot of time and a lot of money to build out a blockchain application. So when you kind of think about the end-to-end work that you have to do, you have to set up the network, right? And so once you have your network running, you're like, all right, I want to interact with it, probably have to build out a web app on top. If I want to do things like run analytics, on my transactions that are in the blockchain network, right now it's difficult to directly access that data, so you might set up some off-chain storage so you can run analytics off of that. You might have to do things like integrate with your identity system, which is additional work you have to do. You have to do things like integrate with the key management system, more additional work you have to do. At this point, you haven't even really thought about your business workflow or even started writing your smart contract yet, right? So a lot of scaffolding work that you have to do that isn't necessarily directly related to your blockchain workflow takes a bunch of cost and a bunch of time. And also helping you get off the island, right? So kind of what I was talking about earlier, if you want to integrate with your identity system, that's work you have to do. And so the idea with App Builder is that it sets up all of this for you, so you don't have to do it yourself, right? So all that scaffolding is set up for you, and once you actually deploy Application Builder, all you have to do is basically focus on writing out your smart contract business logic and provide a set of metadata, which basically will inform the UI visualization. And once you provide these two sets of data, then you have an end-to-end working blockchain application. And so if you think about the value add here, it's pretty high. You save a bunch of time because you don't have to set up all that scaffolding, and you get automatic integration with Active Directory, and you have an out-of-the-box web app that you can use, which is pretty neat. So this is a scenario that is around this refrigerated transportation. And so if you think about this scenario, it's kind of, let's say at the front there's a milk producer, and they want to provide some milk to a retail store, right? So there's a number of different parties that are involved here, and they all don't really trust each other. They're all kind of individual. And so sometimes when you think about the problems here, once the milk reaches the retail store, in the current state of the world, you might have the retail store saying, all right, like, this milk is bad, who's responsible? And it's difficult to figure out who is actually responsible, right? When you think about this IoT-enabled scenario, right? So there's a food processor, the milk is sealed in an IoT-enabled package, and there's a smart contract that goes along with this. And as the milk is getting transported from carrier to warehouse to carrier to the retail store eventually, the smart contract is getting updated constantly while the IoT device is emitting these signals. And so at each point in time when the smart contract gets updated, you can kind of see, all right, like at each point in time when the food processor had it, when the carrier had it, when the warehouse had it, what were the readings for the actual temperature and the humidity, right? And so in this particular example, you can pinpoint carrier 2. You're like, all right, carrier 2, you're out of compliance. You have to pay for whatever damages for being out of compliance, right? So this is a pretty neat scenario when you kind of think about how IoT and blockchain partner together can provide a lot of value here. And this is just a super high-level diagram of the app builder architecture. So, you know, you kind of have your client apps at the front, talking to gateway service API, which pushes events to the event hub, and there's a number of consumers that are kind of getting messages from the event hub, and depending on what the message is, it'll either get consumed by a database consumer, storage consumer, or a distributed ledger consumer. And essentially what happens is, you know, it takes these events, writes it to the ledger, and then, you know, as the watcher kind of listens for events on the ledger, once things are confirmed, it sends it back to the event hub where it gets consumed by the database consumer, and it writes those confirmed transactions into your off-chain storage where you can run your analytics and things like that. And so we have kind of these green boxes around where you can extend here. So from the database, you can extend by running off analytics like Power BI or ML or whatever your analytics choice is. And then things like, hey, if you want to put an IoT device, you can also set it up so that it's sending events directly to the event hub where it can, you know, get consumed by the DLT consumer. And across the bottom, we have App Insights, which is a really neat way for you to kind of troubleshoot what's going on in this entire system. So that is all that I have for today. If you want to get started, we actually have our app builder in private preview right now. So if you want to, if you're interested in joining, you can go sign up, and all you have to do, we are a little constrained in terms of the actual space that we can, the actual number of customers that we have for our private previews. So, but if you have a really compelling scenario and, you know, you're ready to build out a proof of concept and you want to really get started, feel free to sign up via this link, and I'll send out this deck to Jim later, who can send it out or attach it. And so, yeah, a bunch of neat places where you can engage. We have a blockchain page, we have a blog, we have user voice. And if you're interested, you can also join Azure Advisors, where you basically can hear about all the different product updates and kind of learn about what we're doing as we're kind of moving along this journey. So, yeah, thank you. Are there any questions I can answer?
Yeah, so how are these data, are they being backed up and replicated to different databases?
Are you talking about this one? For the database consumer. So the way that it comes out of the box right now is there's like one SQL database, and there's one database consumer, and essentially, depending on the way that the message in the event hub is packaged, if the database consumer consumes it, basically it's a confirmed transaction, or like some events like, okay, this transaction failed, and then that information gets stored on the database.
But they're being replicated to different databases, right?
In this case, it's just one. It's one database, and then, yeah, it's not really replicated, right? So there's the information that's on the blockchain, which is a little difficult to get. And so if you want to run analytics, the idea with the off-chain storage is that once the transaction is either confirmed or you have some message that it's like it didn't go through, the DLT watcher picks it up, packages the message in a way that the DB consumer will pick it up, goes back to the event hub, and then the database consumer will take that and then basically format it and write it to the database. Yeah, so right now there's only one. Yeah.
Can you show the app builder actually?
Yeah, I can show App Builder. Did you have a question?
Just that, after, you know, been around through databases, it seems like with the blockchain, you're building this ledger, and you save all your transactions and you never delete them. Doesn't that make a case for buying disk drives?
Excuse me?
Doesn't that mean that you don't ever purge the data? The ledger always holds every transaction.
Yeah. I mean, that's the idea behind an immutable database.
Right?
Yeah.
So you never clean it out, it always, you know, just builds up forever.
Well, I think depending on what you're trying to do, if that's not realistic, then then don't use the blockchain if it's,
But this
going to be
seems
too
like,
much.
you know, they never clean the database and you're just filling up disk drives I think about cryptocurrency running,
Mhm.
and everybody buying,
Yeah.
coffee every day.
Yeah, it's like huge. If you want to join like a public network, it takes a bunch of time to download all of the data, right?
There are ways around that. It's a
Mhm.
basic data structure
Called a Merkle tree, yeah.
You can actually have lightweight nodes that
Yeah,
can prune the majority of the
Yes.
tree and still get reliable, accurate transactions and consider the tree.
yeah,
Is a chain.
yeah. So, right, thanks. So there's ways that you can basically condense the data, but it's still there somewhere, right?
I have a question. So
Yeah.
in the news today, I don't know if you saw this, but the crypto kitties, where you've got
Oh, yeah.
Ethereum, you're
Yeah.
building digital cats and sharing them around, right?
Yeah.
You're breeding them. So the data, right? The ledger's full of cats now, right? I think.
Yeah, yeah.
Never
They're like
going
digital
away.
cats. Yes. Yep.
Who's paying?
And you can earn a lot of money by buying and selling these digital cats.
Who's paying for that ledger? All the stuff that you may not download it to your mobile.
Oh, you are.
The person that pays.
The person that's running it will pay for it.
So that the owner of the network or whoever the originator is.
No. Well, if you think about the blockchain network, it's like individuals that are running these nodes, right? So as an individual, if I want to join the network, I have to like set up my own machine and then like join it. So I'm paying for my part of the network. This person is paying for his part of the network. Does that make sense?
Yeah, but they all get a copy of this ledger that's continuously growing.
Yes. Yep.
Just-
Yeah.
Yeah, but one of the value propositions is that now you start getting rid of those trusted services that cost a lot of money, because this automatically gives you that trusted engagement so you can transact. So I don't necessarily need maybe somebody like an eBay sitting there. I can execute on something quickly, and yet there's data that's stacking up, but I've eliminated this overhead. You know?
But then would
Yeah.
the efficiency degrade over time as the size of the ledger grew and grew and grew and you know, more energy?
There's a couple of
It depends on your it depends on your scenario. Like I think if you think about the public scenario, like you'll have a lot of these problems, right? If in a more private, if you're setting up like a private consortium, then you won't run into these issues probably as quickly.
But the cloud provider, since everybody gets a copy and it's always
Yeah.
growing, that
Yeah.
everybody's paying
Yeah.
for.
yeah.
Yeah,
Oh,
that's
nice.
good.
Okay.
So
Yeah.
I feel like it's like disruptive to banks and companies like PayPal.
Right.
How are they gonna react?
Yeah.
Yeah.
I think so I think if you're like an intermediary and you
Yes.
truly add no value, then you should be pretty scared, right?
Yeah.
But I think when you think about a lot of intermediaries, like a lot of the times, like I think their role might transition into something like, oh, they might be the ones that are actually authoring the smart contracts for these consortiums. And so, if there's a consortium that gets together and they want to, have some sort, whatever their workflow is, like, if I don't trust you and you're writing the smart contract, you're like, well, do I want you to write the smart contract? Do I want someone else to write the smart contract? So I can see a place where an intermediary, instead of being an intermediary, is the one that's actually authoring these smart contracts and potentially selling them. I don't know. This space is pretty new, so we'll see what happens. Yeah.
Most smart
Yes.
contracts are open source and they are auditable by any entity. So that's where the trust comes in.
Mhm.
You know.
Right. Yeah. Yep.
It seems to me there is a big mismatch, impedance mismatch between blockchain and the particular enterprise application that you've drawn so far. Because for blockchains to really work securely,
Mhm.
they have to be geographically distributed, and there needs to be large number of locations. In an enterprise, you normally would probably use the cloud, right, which is just a few data centers. It's not, it's not secure in that sense. Not totally secure as a geographically distributed set of machines.
So your question is around
Security.
because the computers are not geographically distributed?
When you talk about enterprise,
Mhm.
you're dealing with basically not decentralized, but really central organizations. The blockchain is designed for a decentralized system.
Mhm.
where there's
Right.
no center.
Right. Well, I think like if you're working across organizations, you might not necessarily, like you can also design for cases where like, oh, I want to run my node in my own network, right? Like it doesn't necessarily have to be on a particular cloud provider, like depending on the people that you're working with. Because if it's one organization, the blockchain scenario doesn't necessarily make sense, right? Because you should theoretically trust everyone in your organization. In that case, wouldn't be a blockchain scenario, it would be like a database, right? So then you should just run a database.
So there would be like, say, 5 companies who are interested in one thing, like the delivery frozen materials, right?
Right.
5 companies is still, compared to a real blockchain, which is the cryptocurrency, is a small number.
Oh yeah, it's much smaller. Like I don't think the security is necessarily in like the geographical location. Are you making a statement more around like the reliability? Like if something happens to this data center, like all the nodes will go down?
Because you can't trust the other folks, right? So in fact, there's a lot of election going on at every instant in the blockchain. There's whether the next entry is the correct one is decided by election. If there are many nodes that collect that
Right.
that data, then it will get into the blockchain. Otherwise, it won't. If you only have 5, I mean, you know,
I think
probably
he's
the
saying-
fastest ones with the fastest machines will always win.
Like in a situation with Bitcoin, the security comes from the consensus of the many. But in a situation like what you're talking about, there's not the many, so it's the consensus of the few. So security would then lower, I think, is that what you're saying?
Right, I see. It's still following the same consensus mechanism though.
But there's not that many. The problem with the reason you can't hack Bitcoin is because you have to hack. so
Right,
many.
tons. Yeah.
In an enterprise situation, you're saying you would only have to hack maybe 5.
I see what you're saying. Yeah.
The private blockchain, if you do this, who's verifying the transactions? I suppose you don't got Bitcoin, who's actually doing
Who's verified? Oh, well, when you set up a node, you have like mining. When you set up your network, you have like mining nodes. So they're actually like performing mining. Your node is like mining as well.
Okay.
But just in this case for like a private network, like all of that protocol is still there. It's just the reward that you're getting isn't necessarily meaningful, right? Because it's just all of that protocol is still there. The mining node is still incentivized to mine, but the ether you're getting or the Bitcoin you're getting or whatever just doesn't really translate to much value because you're in a private network, right? So that protocol is still in place and people are still incentivized in the right way. It's just not in such a large, like, trustless environment, right? It's just scoped into a smaller environment. Yeah. Yes?
When you talk about, you can set up this, I want this many replicas and this kind of stuff, that seems like that would be good for some sort of prototyping effort. But when you actually wanted to deploy something, a company would typically want 1 or maybe 2 for availability, and want the other ones to be set up by their participating partners. So, what is the purpose of this being able to set things up as a unified whole? Because it seems like you still have to negotiate with the other parties, and they have to agree on which model they're going to use and all that kind of stuff.
Right, yeah. So if you're setting up a private consortium, there's right now, in the current state of the world as it exists today, there's a lot of manual negotiation that goes on. So are you talking about the template example? As my computer wakes up. This one?
Well,
or just in general?
Well, yeah, I mean, it's sort of, if you take your example of where somebody's going to be selling travel things, it seems like the replicas need to belong to all the hotels and all the airlines and the banks that are going to be participating.
Right.
Those are going to be the replica owners, not some company setting it up.
Right, yeah. So if you want to participate in the network, you would set up your own node. Yeah.
Okay.
Yeah.
Can you talk about block size and how does that limit, specifically related to cryptocurrency? Like was it the limitation
block
of
size.
Bitcoin or limitation of Bitcoin?
Well,
Ether? Are they a function of the
crypto.
Yeah.
Well, is your question around like how the block size gets adjusted?
Or is that if the block size related to how many available, Bitcoin out there, or how many Ether you can?
Well, yeah. Well, the block size generally is determined like, I believe, in like the Bitcoin world and Ethereum world, it's like there's some time limit or time constraint around how long you want it to take for you to mine a particular block. And so depending on the number, like as the network grows, there's going to be more and more transactions that are occurring. And so the amount of time it takes to mine a particular block basically like might take longer and longer. And so depending on the size of the network, if you want to time box it to 10 minutes, that might cut off the number of transactions that you can actually verify and validate at each point in time. So that's how it's adjusted right now. I mean, the protocol could change. There's a bunch of different like alliances out there that are like, oh, we're gonna have the next version of Ethereum or next version of Quorum or whatever. And so like these are constantly being adjusted, but I believe currently in the public crypto world, that's how it's.
So it's a function of both block size and time.
Yeah, I believe so. Yeah.
Is Cryptlets a level above the smart contract? I'm trying to understand the concept around how, if that one node is introduced, does it copy to every node?
Oh, Cryptlets is
It's like a layer.
Yeah, Cryptlets is a layer above the blockchain. Yeah.
Okay.
Yeah. It's yeah, so each person or each like participating person might have their own Cryptlets. If you want to learn more about Cryptlets, there can be an idea of like an Oracle Cryptlet where it's like reference data, like an interest rate or something, right? And that could potentially be shared by multiple parties. There can also be like contract Cryptlets, which actually have your proprietary business logic, and that is likely only going to be accessible by one particular
Like a
party.
custom script, essentially, if you wanted to make a comparison, that just runs an event of some sort, gathers some information, to add on to the business logic.
Sorry, can you say that one more time?
So it's essentially like an event or an action or a custom script that can run on top of the business logic.
A Cryptlet?
Yeah.
A Cryptlet's actually like it's like that entire, it's like a safety deposit box that holds all the code.
Okay.
Yeah, an enclave. And a number of other items.
Sure.
Yeah. Yeah.
You want to say what an oracle is?
An Oracle. Oh yeah. So I mean, an Oracle Cryptlet is like reference data, right? So it's like interest rate, or like if you want to find out what the weather is, like the weather, like stuff that isn't custom business logic. Yeah.
So it's understood Oracle as the Oracle database thing.
No,
Oh
this
yeah.
is
Sorry, Oracle
like
Cryptlet. Yeah.
stock transactions or temperature. That's why I wanted it.
Yeah. Yeah. Sorry. The confusion. Yes.
So whenever we're talking about so every devices that's in the network will have the copies of files, right?
Every device that's in
So,
every
so
node.
in the blockchain, you don't have copies. So is it like the whole chunk of data or like pieces?
Okay, we touched upon this a little earlier. So like.
Yeah. I didn't kind of.
Yeah, no worries. It depending on what your scenario is, and two, like what you decide to do when you join the network. It could be like all the data. You just like get all the data, or it can be in some condensed version of the data. But you would still be able to. You still have to get all the data, right? Whether it be in a condensed form or like the full blown form. Yeah.
So that if I'm trying to get a full, like say, whole data, right? And then what if the other device holds, and then that device goes down? So what is the ways to like the?
Oh, like when it rejoins the network. Oh, when it rejoins the network, what happens is like it will query the last. It'll query like one of its peers to figure out what the last state of the blockchain was, and then it'll basically reconcile to that. Yeah. Yeah.
So on the blockchain, there's a lot of technology that we're still trying to figure out. I feel there's multiple generations of technology. We're seeing a lot of coins evolve and encryption algorithms change. With newer crypto coming out and newer capabilities out there, how secure and safe and reliable do you think these platforms will be? Because obviously there's going to be a breaking point at some point, right? And I think people are obviously riding the wave of Bitcoin right now. So your quantum computer can get out there and crack all your private keys. Honestly, 100 years from now might be the case. So investing in this may not be the best opportunity. A lot of people are jumping on the bandwagon, and we're seeing a lot of speculation, really. I foresee like IOTA, Microsoft has a new investment, I believe, in the Tangle-like technology there. Some of that might be,
So-
if you could talk about that, what is the relationship with the IOTA, and how is that going to play into the blockchain?
Yeah. To clear up a little bit of confusion around the IOTA announcement. So IOTA is running on Azure, but we're not like, there wasn't like an official endorsement that was made or anything. So
I'd say that the underpinning technology behind IOTA, where they've kind of like pre-calculated the blockchain in a way, and you're just sending the transactions. It's a different way of sharing data. So like we talk about the efficiency of the blockchain network growing. Some of the other technologies out there have addressed that, but they're not as popular or well known.
Yeah. So there's a lot of like effort around improving actual ledger technology. So that's actually really neat to see, because then a lot of the enterprise challenges, or a lot of like the challenges in general that you see, are being solved actively by different groups. In terms of like, sorry, I don't know exactly what your question is around.
How volatile is this? If we build an app now, is it going to be out of date? And obviously, the rate
Oh, I see
the
what
rate
you're
of
saying.
progress that we're
I see what you're
developing,
saying. Yeah. Oh, because there's no like standard that's determined right now. Yeah. No, that's a really good point. I actually think, in my personal opinion, I think you're right. Like, it's difficult to say if you build out an app right now, if it'll be like, if the ledger you choose is going to be the standard in 10 years or whatever, right? But what I think will happen is the people that move earlier will be the ones that are kind of like defining what that standard will be, right? So if there's a lot of people that are building out blockchain applications in the earlier stage on a certain ledger, like as people start working in this space more, they might gravitate towards that, right? It's like, oh, more people are using this, like there's these benefits, I'm going to use that too. So I think it's more of a behavioral thing as opposed to, behavioral thing in terms of where the state of where we're at now, more so than a statement around how stable or unstable the actual technology is. If that makes sense. Yeah.
I'm just waiting for the quantum computer to come online, because Bitcoin is worth nothing.
Yeah, it's a little speculative. I mean, it's like speculative.
It'll migrate to quantum proof blockchain, which already exists, by the way. There's already a quantum proof blockchain.
Which one is that?
So I can send you a few links.
Sure.
And it's also
Send it to us and we'll post it, or you can post it on the meetup.
Dynamics working on quantum proof algorithms for Ethereum too. There's already a few things coming out. Yeah. So I mean, just keep in mind, for everything there's a problem. Now there's a bunch of other minds thinking about that too. And so it's not going to die because of that.
Quick question on, as we move away from the crypto world, building applications for other scenarios that we're going to talk about.
Yeah.
Things like banking and capital markets, derivatives trading, to what extent, in your experience, are there limits on the smart contract itself? Is it prime time, right? When you start looking at those applications, is the smart contract extendable? Do we have any limits that you see at this point in time?
Yeah, I think there's a lot of limitations with existing smart contracts. Like once you kind of deploy it, you can't really edit it. You point things to an address. So if you want to edit it, you have to like redeploy it. I think a lot of the stuff that we talked about earlier, especially when you think about like banking scenario, like financial services, a lot of times you'll have to do things like check interest rates or like do things like that, right? And right now, without something like Cryptlets, it's difficult to do that. So I think a lot of the problems that we're trying to solve are trying to address these issues that we see, especially in the financial services industry, since a lot of the early movers in this space are in financial services. So, yeah.
Brenda, can you show the
Yeah, sure. So,
Who's doing work with blockchain?
You can be the next presenter. But post the information, send it to Toddy or I, and we'll get it out to the group.
I mean, we
It's
said
simple
today,
to always
just
have
getting
any-
people to use normal digital signatures.
I know.
Easy to do and pretty secure, we can, anyway.
So what's
So,
the,
so now it's a whole other layer on that. The whole same problems of crypto nimbleness, crypto changes and some people understand their smart contract and things.
all right, so what I did just now is I'm logging into an instance of Application Builder, and I'm already logged in, but basically I'm integrated with Azure Active Directory, and so you can see kind of my little avatar on the side here. My identity is showing up as my corporate identity, and so when you first log into Application Builder, you kind of have this view of all the different smart contract templates that you have access to, and I'll just walk through the admin experience quickly first. So out of the box, we kind of provide a number of demo contracts for you to just deploy and play around with. So if you go here, you can kind of see, hey, we have a number of demo contracts. You can see which ones are deployed in this particular app builder instance. If you have written out a custom business logic workflow, you can upload a custom contract. This is where you would upload your contract and your configuration files. And so after you've basically either deployed a demo contract or uploaded your custom contract, you can go to user assignment and assign users. So what you see here is kind of, you know, if I want to create a new assignment, I can select from the different contracts that I've deployed in this app builder instance. So let's say I choose telemetry compliance scenario, and basically the personas will populate based on the contract that you select. So I have a device, and then here's all the users that are in my system. I'm gonna assign one, and then I submit, and the user assignment is created. And so now if I go into the telemetry compliance view, I can see, all right, here's all of my different contract instances that are kind of existing here. I can create a new one. So this is actually the example we were talking about earlier, right? So you have kind of your minimum humidity and maximum humidity, your temperature ranges, and then you can fill out your you can say what your IoT device is. You can say who's the owner, who's the observer, and put on all your info here, which will basically create a smart contract instance. Just do something simple. And so now after I submit it, you kind of see this creating contract spinner on the right. Basically what's happening here is that it's submitting all that information to the blockchain, and blockchain is validating it. So while that's happening, I'll just go into one that I've created already so you can kind of see what's going on here. So in this particular example, what you see is at the top, I have all my contacts that are involved in this particular smart contract instance, and I can see kind of details of the smart contract, so what the state of the smart contract is, you know, all the different people that are involved, what the different compliance requirements are, you know, what the readings are, whether or not it's in compliance, some details, and then also timestamp. And so you also have this view here of where the state of the smart contract is in. And this view is kind of, the contract progress view kind of shows the audit trail around the different actions that were taken. It gives you a transaction receipt, which basically points to an address on the blockchain for this particular transaction that occurred. It gives a timestamp as well as, you know, a user view of who actually performed the action. And so this is just that audit trail view, and the blockchain transactions is similar. It has that audit trail view, just gives you a little more detail, basically gives you a from address and a to address if it's lower down, and also the block number. So this kind of view, actually, for this particular smart contract, I actually don't have any available actions to me. But depending on your business logic, depending on the state of the smart contract, depending on your role, depending on those two things, basically you'll see an actions card here, which basically will have a number of actions that are available to you at that point in time, and that's also defined by your smart contract. So let me see if I can actually show you one from here. I have more examples here probably. Yeah, so in this example, this is a different smart contract around asset transfer, which is basically, like let's say you're selling some high value goods and you need an appraiser and inspector, and you have this kind of offer that you're placing, there's buyer and sellers involved. So in this particular case, I am an owner, and I wanted to sell my service book for $800, and so, a $5 offer was made, and so I can basically, in this current state of the smart contract as offer placed, I can take 3 actions. I can reject the offer, I can accept the offer, or I can terminate the offer. So if this is in a different state, so let's say maybe this one active, I have different ones. So because this is active, there's no offer placed, I only have one action available to me, right? So this is kind of that web app view that you get out of the box. And so one thing that's neat here is because we have that API in the front, if you want to build out your own UI front end, you can just talk directly with our APIs and build out like your own like personalized looking application. So yeah, it's just a really quick view of Application Builder in case you guys are interested. So
Does this allow me to build apps for Ethereum blockchain? Or?
Right now we support Ethereum only. The goal, the long-term goal is that it would be like chain, like we would support a number of different blockchain protocols such as Hyperledger and Corda. So yeah, longer term it will have more ledger options.
Is this used in Web3 here in the browser?
Yeah.
Is Amazon competing with you guys in this space? What's the...
So right now Amazon doesn't have a super clear stance on blockchain. I don't know if you saw their like kind of anti-announce at reInvent a few weeks ago, but basically they were asked specifically about their blockchain offerings, and essentially the response was that they are not investing in it currently. So yeah, so right now there's no direct competition with Amazon. Yeah.
So the architecture for this app, you don't have like a back-end SQL database. There's this is really the Ethereum data. So there's some wallets, right? I think is the right term. You've got data replicated out in its network, and it's viewing that. You've got
no, so this is actually, sorry, this one. This is actually the backend architecture of App Builder, the one that I showed earlier.
So your application is this architecture, not the environment that you used to host it in? Development environment. This is the app that you built here?
So the application builder, when you deploy it, it deploys all of this stuff for you, right?
Okay.
So essentially, I mean, I can kind of show you.
So then, in Azure, what would it cost to run that base architecture?
Good question. So it's really dependent on a number of different things. Give me a second. Such as like, hey, what regions you're running it in. Like, if you're pushing a lot of events through Event Hub, like if you're really actively using the app, like your cost will go up. If your network is larger than the default, it will go up. But I think right now it's around like $1,000 a month to run this. And that's more of like a pilot scenario, so you're running like kind of like pretty serious workloads on it. Let's see. So yeah, let me pull up this resource group if it loads. So yeah, App Builder deploys a bunch of stuff for you, right? So if you can imagine, if you're building out kind of this thing by yourself, you have to set up a lot of different, like many different resources, right? So App Builder will do that all for you. And then this endpoint that I'm hitting is this web app. This web app here. So, yeah. And this is the architecture diagram for that. So.
Like I said, that's actually really cool.
Yeah. So hopefully saves people a bunch of time.
Okay.
Are there any resources available online where we can look and mimic the app builder functionality and try and get our hands dirty on this?
I would actually go to aka.ms/blockchain preview if you want to get early access to App Builder. Our space is a little limited right now, so like write a good scenario description and to make sure, yeah.
It's like on demand?
Excuse me?
It will be provided on demand, or is it like it's not open for everyone?
It's a private preview right now, since we're not quite. The quality is not quite like production level, so there's still lots of bugs we're fixing. We can't handhold basically it's a little handholding right now, and so we can't scale out and just like open it super publicly right now. But if you're interested, there's that form that you can fill out, kind of describing your scenario, your use case, like what you want to use App Builder for, and then if you want to get your hands dirty and you want to like build out a scenario, build out a custom contract, then definitely sign up there, and then like we triage the requests and then give people access. Yeah.
Sure.
Yeah. No problem. Yeah.
All right, last question.
Thank you.
Make it a hard win.
So you mentioned about Azure blockchain as a service, right? So
Mhm.
that also create all these resources required to build a blockchain, right? So how it actually differs from App Builder? So App Builder provides a kind of applications on top of
App Builder is a solution template. So I don't know how familiar you are with Azure solution templates.
Yeah.
Yeah, so it's a solution template. It's super simple. You look it up in the marketplace, click through some steps, and then it deploys it. Yeah. But since it's in private preview right now, it's not searchable. Yeah.
So by using blockchain as a service, we can build some applications on top of it, right?
On top of App Builder?
Blockchain as a service, Azure blockchain as a service.
Azure blockchain as a service. Oh yeah. Well, right now, there are products right now are like all the solution templates. So yeah, definitely you can build apps on top of that.
Yeah.
Yeah.
Good.